The Webb telescope was built with a bold mission: to look back across time itself, to witness the birth of the first stars and galaxies, and to search for new worlds beyond our own. It was designed to answer humanity's oldest questions. But what happens when the answers it sends back don't simply fill in the blanks? When they shake the entire framework of what we think we know? What happens when our most advanced cosmic eye starts spotting objects that, by all existing theories, shouldn't be there at all? That's exactly where we are right now. Astronomers are grappling with two extraordinary discoveries. One is a kind of cosmic ghost lurking practically next door, a possible planet detected in a place where physics said it should barely be able to exist. The other is a collection of galaxies from the universe's earliest moments that appear far too large, far too developed, as if they grew up impossibly fast. Together, these findings don't just raise questions, they threaten the story we've been telling about how the universe works. And that's why we need to talk about what James Webb has just revealed, because this may be one of the most unsettling scientific moments in years. These aren't minor mysteries or technical hiccups. They feel more like fractures running through our understanding of the cosmos. As scientists race to explain what they're seeing, a bigger question hangs in the air. Are we witnessing the beginning of a new era in astronomy? Or are we about to rewrite some of our most trusted theories from the ground up? The story begins surprisingly close to home, just 4 light-years away in the Alpha Centauri system. This is our nearest stellar neighbor, a complex trio made up of 2 stars much like our Sun, Alpha Centauri A and B, locked in a tight orbital dance, with a smaller red dwarf, Proxima Centauri, circling farther out. For decades, astronomers have been obsessed with finding planets here. While worlds have been discovered around Proxima, the 2 main stars have stubbornly refused to give up their secrets. And gravity is the villain in this tale. 2 massive stars orbiting each other generate extreme gravitational chaos. Imagine trying to carefully build a sandcastle in the middle of a raging hurricane. That's what planet formation is supposed to be like in such an environment. Any disk of gas and dust should be ripped apart, and any planet that somehow forms should be violently ejected into space. Finding a large planet there would directly challenge everything we believe about how and where planets can form. Then came August 2024. Astronomers aimed the Webb telescope at Alpha Centauri A, using one of its most powerful tools, a coronagraph. Think of it as a precision-built cosmic shield that blocks out a star's overwhelming glare, allowing faint nearby objects to come into view. It's like covering the sun with your thumb, except done with astonishing accuracy across light-years of space. As the data was processed, something unexpected began to stand out. A dim speck of light emerged from the noise, more than 10,000 times fainter than the star itself. A whisper where there should have been nothing. After exhaustive analysis, the team announced strong evidence for a giant planet candidate. The data suggested a gas giant, possibly comparable in size to Saturn, orbiting at roughly twice the distance between Earth and the Sun. While such a planet wouldn't be habitable itself, its position opens up an exciting possibility: large, rocky moons that might be. If confirmed, this would be a historic find, the closest exoplanet ever directly imaged, and the first discovered around a star so similar to our own Sun. But this is where the story takes a turn. In science, nothing matters more than confirmation, so the team pointed Webb back at the same location in February and April of 2025, fully expecting to see the planet again. Only this time, it wasn't there. The faint glow detected in August had completely vanished. One scientist described it as the case of the disappearing planet. Was it a fluke? A data artifact? A cosmic trick of the light? To find out, researchers turned to powerful supercomputer simulations, running millions of possible orbital scenarios. And what those simulations revealed left them stunned. The simulations delivered a twist worthy of a cosmic thriller. In nearly half of all stable scenarios, the planet's stretched, elliptical orbit would have carried it too close to its star during the follow-up observations, slipping perfectly behind Webb's light-blocking mask. In other words, the planet didn't vanish, it hid. What looked like a ghost may simply be a master of cosmic hide-and-seek. The evidence is still compelling, but the final verdict remains just out of reach. And if this world is confirmed, the consequences are huge. It would prove that giant planets really can form amid the gravitational chaos of a binary star system, something our theories have long said should be nearly impossible. Help may be on the way. Future observatories, especially NASA's Nancy Grace Roman Space Telescope, scheduled for launch by May 2027, could tip the scales. By combining Roman's data with Webb's, astronomers may finally confirm whether our closest stellar neighbor is secretly hosting a planet that science said shouldn't exist. But while one of Webb's eyes was fixed on our cosmic backyard, its other was staring far deeper, back across space and time to the universe's very beginning. And there, it stumbled upon its second shock. Not a single odd object, but an entire collection of them. Galaxies that are simply too big, too evolved, and too mature for their age. They're the cosmic equivalent of walking into a nursery and finding fully grown adults calmly sitting in the cribs. To understand why this is so unsettling, you need to know the standard story of the universe, the Lambda CDM model. According to it, the universe began smooth and simple. Over hundreds of millions of years, gravity slowly pulled tiny clumps of matter together, forming the first stars and small primitive galaxies. These early systems were supposed to merge gradually over billions of years, building up the massive galaxies we see today. It was a slow, patient process. And for decades, observations from telescopes like Hubble seemed to support that picture. Then Webb arrived. Unlike its predecessors, Webb is an infrared observatory, designed specifically to see the stretched, ancient light from the earliest galaxies. And what it found has thrown cosmology into a state of electrifying confusion. Webb has now spotted thousands of galaxies from the universe's first billion years, but some of them just don't belong there. As early as 500 million years after the Big Bang, Webb detected galaxies that were shockingly massive and filled with old red stars. These weren't the small, chaotic swarms of young blue stars that theory predicted. They looked like galaxies that had somehow skipped childhood entirely. Astronomers, as always, are cautious. One explanation is that rapidly growing supermassive black holes at the centers of these galaxies might be making them appear heavier than they really are. Even so, the tension remains. There still seem to be far more large galaxies in the early universe than our models can account for. And then the mystery deepened further. Webb also found quenched galaxies, systems that had already stopped forming stars. These are cosmic fossils, frozen in time, appearing in an era when star formation should have been roaring at full throttle. Finding even one so early is deeply puzzling. But the most striking challenge comes from a galaxy known as Jade's GSZ 13-1, seen just 330 million years after the Big Bang. At that point in cosmic history, the universe should have been shrouded in a dense, opaque fog of hydrogen gas left over from the Big Bang. This fog should block specific kinds of light from young stars, making a galaxy like this nearly impossible to observe clearly. And yet, Webb detected a bright, unmistakable signal of that very light pouring out of this galaxy. It was slicing through the fog when it shouldn't have been able to. For that to happen, the galaxy must have already carved out a vast, transparent bubble around itself, a clearing hundreds of thousands of light years wide. For a single galaxy to achieve that so early was once considered unthinkable. Now scientists are racing to explain what could power such an event. One possibility is the presence of population 3 stars, theoretical first-generation stars that were far hotter and more massive than anything that exists today. Another is that the light came from one of the universe's very first supermassive black holes. Either way, the message is clear. The process of clearing the cosmic fog, the era of reionization, happened faster and more violently than we ever imagined. These early overachieving galaxies are pushing the standard model of cosmology to its breaking point, forcing researchers to refine their simulations and rethink how the universe grew up so quickly. So where does this leave us?
On one side, a possible ghost planet in our own backyard, defying everything we thought we knew about planet formation. On the other, ancient galaxies at the edge of time, rewriting the timeline of the universe itself. One mystery is about mechanics, the other is about history. Together, they reveal a cosmos that is far more inventive and far stranger than we ever expected. The title Universe Breaker may sound dramatic, but it captures something very real. These discoveries are creating what scientists call tension, a widening gap between theory and observation. And history shows that this is exactly where scientific revolutions begin. The disappearing planet of Alpha Centauri and the galaxies that grew up too fast aren't problems for astronomy, they're invitations. Clues pointing toward a deeper, richer understanding of reality. The Webb telescope was built to show us where we come from, and in its breathtaking, baffling images, it's doing exactly that by reminding us that, despite all we've learned, the story of the universe is still being written. NASA Jet Propulsion Laboratory, California Institute of Technology.